Precast panels. Working with or around precast panels or braces is high risk, as an error of judgment or failure of a crane, rigging, bracing or panel component can put the public and workers at serious risk. There are several factors that have the potential to cause a precast concrete panel failure, including poor design of panel shapes and panel breakup, insufficient concrete strength at the time of lift, inadequate, incorrect or missing reinforcement in the panel and lifting inserts, inadequate specification of the strongbacks and associated fixings, using strongbacks and associated fixings that don't align to the engineer's specification, and incorrectly rigging the panel. Recommended ways to control risk. Hallmarc should ensure that all precast concrete panels are appropriately designed to resist all forces they will likely be exposed to. A suitably qualified person, such as a structural engineer experienced in erection design, should be engaged to develop a safe system of work for the handling, transport, lifting, rotation and erection of precast concrete panels. This person is referred to as the erection design engineer, or EDE. The EDE should review the precast concrete panel designs and specify any additional reinforcing or strongbacks required to ensure the panel is safe for transport, lifting, rotation and erection into its final position. The EDE may not always be directly engaged by the builder or principal contractor. However, both the builder or principal contractor and precast erector should ensure that a suitably qualified person has been engaged and has undertaken the functions of the EDE before erection works begin. The following critically important factors should be addressed to reduce the risk of a precast concrete panel failing during rotation. Please note that this is a non-exhaustive list. Prior to panel manufacture, the project structural engineers and builder should consult with the erection design engineer and precast panel manufacturer to ensure that the precast panel breakup design achieves panel shapes that are robust and can be handled safely, where possible without the need for strongbacks and additional reinforcement. The EDE should carefully consider all forces that the panel will be exposed to during lifting, rotation and placement, and review the design of the panel to determine whether additional reinforcement or strongbacks are required to ensure that it can be handled safely, especially where the panel has cutouts or penetrations. And provide the precast manufacturer with marked-up structural or shop drawings that accurately and clearly show the necessary lifting and bracing insert locations and any additional reinforcement or strongbacks required. Where strongbacks are required, the strongback type and associated fixings should be accurately and clearly specified. Produce rigging designs for the various lifting stages required, such as demolding, pre-transport, rotation, and installation. Review and approve the updated shop drawings prior to them being issued for construction to ensure that the lifting and brace inserts and any additional reinforcement and strongbacks are correctly detailed on the drawings. Following completion of the above steps, issue the EDE Certificate of Compliance. During panel manufacture, the precast manufacturer should ensure the shop drawing for the panel has been reviewed and approved by the project design engineer and EDE prior to commencing manufacture. A suitably competent person, who was not involved in the original setup, has ensured all reinforcement and components comply with the approved shop drawings before casting, and that the minimum specified concrete strength is achieved before the initial lift off the casting bed. All strongbacks are installed as per the EDE specification prior to lifting or transport. Non-specified and non-structural strongback components and fixings are not used. Minimum specified concrete strength has been achieved prior to transporting the element to site. They have completed and issued the manufacturer's certificate of compliance to Hallmarc. And any variations to the original design, including changes to strongback or component specifications, are approved in writing by the EDE. Prior to lifting the panel on site. When the precast concrete panel arrives at site, but prior to lifting, an appropriately ticketed rigger should inspect the panel to ensure it aligns with the shop drawing, for example, dimensions, cast-in plates, inserts and ferrule locations all match the drawing, and that the panel and components are free from damage. Confirm the lifting inserts match the shop drawing specification and are free from damage. And confirm the concrete adjacent to the lifting inserts is in good condition and free from significant cracking, honeycombing or damage. If in doubt, seek advice from the EDE. Ensure strongbacks are all in place and as per the shop drawing specification. Look for type, size, location, orientation and fixings. Review the birth certificate for the panel to confirm the casting date. Confirm the lifting clutches are compatible with the lifting inserts, and inspect all rigging gear prior to use. Ensure the panel is rigged in accordance with the relevant rigging design, being sure to use the correct lifting inserts where there are multiple inserts present. And stop the lift and seek advice from the EDE if any of the above safety critical information is missing or if there are any issues identified during inspection of the panel. Delivery. Look out for these potential issues. Defective trucks or A-frames, such as damage to the truck or trailer, and fall risks not being controlled. Inadequate load restraints on A-frames and panels, for example, panel lashing sequence, and over-center dogs or twitches being used. Panels delivered out of erection sequence. And inadequate site access for panel trucks. Is craneage sufficient for the erection? Selection of cranes should be in accordance with Australian Standard 2550 and consider capacity required at working radius when lifting. Sufficient craneage to safely rotate panels. Is there sufficient ground stability for cranes entering site? Are outriggers sufficiently packed to ensure stability and compliance with no-go zone clearances and rules? Panel erection. Has the necessary preparation been completed prior to erection? A risk assessment should deal with all aspects of preparation to ensure the access and erection area is safe. The erection platform can support loads. Sufficient space is available for setup and movement. Sufficient space is available for bracing. Dowels and leveling shims are correctly located. There is adequate temporary base restraint, such as dowels or angle iron brackets. Panel and brace footing has attained specified strength. Rigging equipment is in serviceable condition. Check for clutches proof tested every 6 months. Slings, chains and sheaves are free from damage and excessive wear. Lifting and spreader beams are marked with working load limits. Lifting inserts are in their correct location, as specified on shop drawings, and recesses cleaned. And only the minimum number of people are working in the erection area. Are the members of the erection crew properly trained and certified? The person responsible for direction and coordination must hold a certificate of competency in either intermediate rigging or advanced rigging classes. The person responsible for the coordination of the panel erection must also have received training based on the industry standard. The crane operator must hold a certificate of competency appropriate for the type and size of crane being used. The crew should include at least one additional certified rigger. Is the rigging system as specified in the shop drawings and erection plan? In selecting the rigging system, you need to take into account: lifting clutches must have a design factor of 5.0. Loads should be distributed equally to all lifting points, unless otherwise specified. The system should suit the spacing and layout of lifting inserts. Slings will be subjected to increased force on inclination and change of direction. And does the panel lie in its correct orientation for erection, or is there sufficient crane capacity to rotate the panels? Are panels erected according to a planned sequence? The erection sequence should be pre-planned. Panels must not be lifted before attaining the minimum concrete strength. Lift with the rigging in view of the crane operator, whenever possible. All personnel must be outside the drop zone. Do not lift in wind conditions outside the capacity of the crane. Is there sufficient lateral base stability? What methods are used to ensure holding bolts are tensioned in accordance with the shop drawing specification? Are dowel pins properly installed and grouted? If angle iron footing brackets are used, then A. Do they provide sufficient footing stability? And B. Are they welded or fixed in place prior to the panel being released from the crane? Are shims specified in drawings, and not greater than 40 mm high? Where temporary bracing is required, is it able to resist all loads? The panel must be held firmly and safely by the crane while all braces are attached. Braces must have identification plates and load capacity marked. Working load limit must be in accordance with Australian Standard 3850. A minimum of 2 braces must be used for each panel. Bracing anchor bolt size and length must be as specified on the shop drawings. And are knee bracings required? Braces should, where possible, be located at 2/3 of the height of the panel. Temporary concrete pad footings for bracing must be designed to support brace footings. Footing design documentation must show concrete strength at installation, additional reinforcement and dimensions. If a screw-in steel footing plate system is used, soil testing results must be kept with shop drawings and erection plan. Ongoing maintenance of bracing components and final removal of bracing. It is Hallmarc's responsibility to ensure that braces, bracing bolts and pins are checked at regular intervals for required capacity and/or damage. This is contained in the weekly site inspection. Brace pins are secured and locked, and can only be removed by using a tool. And braces are not to be removed, under any circumstance, prior to final written instruction from the erection design engineer or project design engineer. A precast panel installation checklist is found in Build Pass. This checklist should be completed for each day of panel lifting on site.